Hello, my name is Jaqueline, and I'm going to present the work Practices for Geometry Teaching using GeoGebra that was developed by the master's students from Profimat, Lucas Rodrigues Pereira at UFVJM, advised by me and Professor Débora Faragó Jardim. The outline of this presentation is going to be as follows. On the introduction, I'm going to talk about the historical context of teaching geometry and the motivation for this work. Second, I'm going to present the research methodology, GeoGebra, didactic engineering, and the didactic intervention. By the end, I'm going to talk about the results obtained with the didactic intervention, and I also present the references of this work. Well, geometry has always been connected to the way the human being sees the world. So, since Euclides, there was a great interest on the part of the mathematical philosophers in geometric forms and in the axiomatic and perfectionistic way that formal mathematics characterized it. With the advent of the computer, new spaces of coexistence have emerged, and that allow social interaction that was not previously accessible. With this, our main concepts and expectations have been modified. Thus, mathematical formalism is no longer an essentially cognitive activity as before. The relationship between people and what they observe in the natural world or in objects created by man can be simulated through geometric manipulation software. Thus, the whole of the school in this new context is to provide the establishment of the relationship between teacher, student, and technologies. Along with this factor, the teaching of geometry does not receive its due value in the basic student's education. This devaluation in basic education has had a great impact in the courses from exact sciences, in particular in undergraduations in mathematics, where there is a huge retention rate. The real learning of geometry must go through the stage of experimentation, problem solving, building conjectures, and finally we try to justify and formalize the proofs. Therefore, it's necessary to implement new teaching and research methodologies which seek to improve the teaching of plane geometry, particularly in the university and the undergraduate courses. Then the use of computational researches becomes essential due to all these factors mentioned before. So a software that stands out in the category of educational software of dynamic geometry is GeoGebra, that allows, beside many other functionalities, to work concepts of the Euclidean geometry in a virtual environment of three-dimensional or two-dimensional characterization, providing to the students a better understanding and a better interpretation of the concepts that were studied in the classes. So, a researcher called Michel Artigue defined didactic engineering as a form of didactic work very similar to the work of the engineer, who carry out a project and it's based on a scientific knowledge of its area. He submits itself to a scientific method and in this development agrees to work with objects that are more complex than the research objects. In addition, didactic engineering has three phases. The preliminary analysis is the phase, is the stage where the researcher performs the preliminary analysis. That is the investigation process. Then we have the construction and the a priori analysis. It's the stage where it's used to verify if the choices made by the researchers allows to control the behavior of those involved in the research. In this case, the one that are involved in the research are the students. And the last stage is the posteriori analysis with the experimentations and validation. In this stage, at this moment, the researcher, through the data obtained and collected in the previous stage, he put everything in practice, and all the planning, he put everything in practice. So this didactic intervention was planned, very planned, based on difficulty that the students presented in the classroom along other geometry plane courses. And it can't be observed that one of the subjects of the greater difficulty on the part of the students was the axiomatic treatment. Thus, the challenge of this stage was to plan a very interactive activity with the help of GeoGebra software that would provide the necessary subsides to fulfill the gap of knowledge that the students presented by the time. So the need for an introductory course about the use of GeoGebra was identified very early. So we gave this introductory course with the purpose to promote familiarization with the necessary tools, GeoGebra necessary tools to develop the didactic intervention activities. So with the beginning of the didactic intervention with GeoGebra, the students should access one web link, which contained all the planned activities. And the first topic of the intervention were collinear points, non-collinear points, and lines. These contents were purely theoretical, but the definitions and explanations were reinforced with GeoGebra animations and other researches, allowing the students an interaction with the software, as we can see in Figure 1. Thus, is just one of the theoretical topics, and we can see concepts related to points and lines with dynamical activities presented in Figure 2. This was one small exercise, so they should try to practice the concepts of points and lines. And at the end of this introductory stage about axiomatic treatment, the students should solve the first exercise proposed in the didactic intervention, and the solution should be made entirely by GeoGebra, because the proposed exercise has a relatively difficult analytical solution. So the students could analyze and reflect the importance of using the software for plane geometry. As follows the Figure 3, they should show that in any triangle, if the barycenter, orthocenter, and circumcenter were collinear, and which of them is between the other two, and to show that the distance between barycenter and orthocenter is double the distance of the circumcenter. So with the beginning of the activities, the first difficulties presented were not referred to the use of the software, but to the contempt of notable points, because some students did not remember very well the necessary concepts. So we let them to discuss to each other about the correct definitions of barycenter, incenter, orthocenter, and circumcenter, and there was no need for a teacher intervention by the time. And this way, all of them were able to correctly answer the question by saying that the 3 points that were collinear, as well as the other items, as we show according to the Figure 2. And also, the students, they build a kind of a small gift where they can show that this behavior doesn't change when we translate the triangle. So initially, a correction of the questionnaires was necessary and was done, and later the didactic engineering methods were adopted for detailed studies of the data collected. In this way, the improvement of the majority of the students was very clear with respect to the dissertations of the questions, to the demonstrations, and also to the objective questions. So conceptual progress was observed in the students due to the choice of the adequate geometrical exercises, and of course due to a very strong pedagogical organization by Lucas. In this way, we observed the effectiveness of the GeoGebra application for the study of the axiomatic treatment of the plane geometry was concluded, and thus, in addition to what was presented, it should be emphasized that the experiments in this research confers the training of teachers and researchers in the future, contributing to future discussions about teaching practice for plane geometry. These are our references, and we would like to say thank you to UFVJM and Prof. Mat to help us to providing the computing laboratory, the Brazilian Society for Mathematics for providing some bibliographical references, and to FAPEMIG for the financial support. Thank you very much.